Welcome to the Rim Break Rodeo. We hope this video helps.
You start by confirming device Android version and the app's target SDK version so you know TLS behavior. This matters because Android enforces certificate validation differently across releases. Next, retrieve the server certificate chain and save each PEM or DAR file. You need the full chain to test. Once done, enable developer options on the device, turn on USB debugging, and capture network traffic with a DB or a proxy to observe the TLS handshake. These steps get you ready to reproduce and diagnose the error. Now you diagnose the handshake. Run OpenSL client or an equivalent to view presented certificates and verify expiration and hostname. Compare that chain to Android's Trust Store and any app-specific network security config. Mismatches mean Android rejects the cert even if browsers accept it. Then test alternative setups. Serve with a public trusted CA chain, add the intermediate to the server, or temporarily modify the app's network security config for a pinned cert test. Make changes iteratively and rerun your capture to confirm. To finish, install the complete certificate chain on the server and prefer a public CA with current cipher suites and TLS1. 2+ support so Android accepts it by default. If you control the app, update network security config to trust custom CAs or implement proper certificate pinning, and rebuild. After deployment, verify on multiple Android versions. If problems persist, make sure device time is correct, that the server sends SNI, and that TLS versions and ciphers match Android expectations. These often resolve remaining issues.
Thanks for watching. Consider subscribing if we helped you.